So hello everyone, welcome all to Physics with Astronautics. And in this video we will discuss about the question of H.C. Verma, and here we will discuss the first chapter and the exercise. So let's begin. And here is our first question of the session, that is, express the power of a 100-watt bulb in CGS unit. So here 100-watt is in SI unit and we have to convert it into CGS. So let's begin the solution. So we have the power 100 watt, and we know that power can be defined as work done in unit time. So power is equal to work done by time, and here the dimension of power will be M1 L2 T minus 1. So unit of power in SI unit is joule per second or watt. So when we convert 100 watt into CGS unit, it will be 100 watt is equal to 100 joule per second, and we know that 1 joule is equal to 10 to the power 7 arc. So by putting at 1 joule is equal to 10 to the power 7 arc, we'll get the value as 100 into 10 to the power 7 arc per second, that is equal to 10 to the power 9 arc per second. Then here is our second question, that is, the normal duration of ISC physics practical period in Indian colleges is 100 minutes. Express this period in microcentury. 1 microcentury is given as 10 to the power minus 6 into 100 years. And the second question is, how many microcenturies did you sleep yesterday? So let it, and we know that 1 hour is equal to 60 minutes, and that's why 1 day is equal to 24 into 60, that is equal to 1440 minute. And because here we know that 1 microcentury is equal to 10 to the power minus 6 into 100 years. So first of all we will convert the year into minute, that is 1 year is equal to 365 days, and that's why it is 525 600 minute. And 10 to the power minus 6 into 100 years will be 525 600 into 10 to the power minus 4, that is equal to 5254 into 10 to the power minus 2 minute. And 10 to the power minus 6 into 100 years will be equal to 5256 into 10 to the power minus 2 minute, that is equal to 1 microcentury, and 100 minutes will be 1 by 5256 into 10 to the power minus 2 into 100, that is equal to 1.9 microcentury. So here our right answer is 1.9 microcentury. Then the surface tension of water is 72 dyne per centimeter, and we have to convert it into SI unit. So the surface tension of water is given at 72 dyne per centimeter in CGS unit, and in SI unit we know that 1 Newton is equal to 10 to the power minus 5 dyne, or 1 dyne is equal to 10 to the power minus 5 Newton. Similarly, 1 meter is equal to 100 centimeter, or we can say that 1 centimeter is equal to 10 to the power minus 2 meter. So that's why 72 by 72 dyne per centimeter can be written as 72 into 10 to the power minus 5 Newton by 10 to the power minus 2 meter. And by converting it into Newton per meter, we can find the result as 72 into 10 to the power minus 3 Newton per meter, and is equal to 0.072 Newton per meter. Then the kinetic energy K of rotating body depends on its moment of inertia I and its angular speed omega. Assuming the relation to be K is equal to small k I to the power A omega to the power V, where K is a dimensionless constant. Here this small k is the dimensionless constant. Find A and B. Our question is to find A and B, and here also it has been given that moment of inertia of a sphere about its diameter is 2 by 5 mr square. So here the kinetic energy is given as K is equal to K I A omega V. Here K is constant, and we know that the moment of inertia I is given as 2 by 5 mr square, and so the dimension will be m1 l2. And omega is the angular speed. We know that omega is equal to 2 pi by t, and so the dimension of angular speed can be written as t to the power minus 1. And also we know the dimension of kinetic energy is m1 l2 t minus 2. And when we compare these equations, that is k is equal to k I to the power a omega to the power p, you can find it as m1 l2 t minus 2 will be equal to m1 l2 to the power a t to the power minus 1 to the power b. And by equating these two dimensions, we can find the value of a as 1 and b as minus 2. Then theory of relativity reveals that mass can be converted into energy. The energy E so obtained is proportional to certain power of mass and the speed c of light. Guess a relation among the quantities using the method of dimensions. So here the energy E so obtained is proportional to certain power of mass m and the speed c of light in the theory of relativity. That is, E can be written as k, which is a constant, m to the power a, c to the power p. Here m is the mass and c is the velocity of light. So we know the dimension of energy can be written as m1 l2 t minus 2, and similarly the dimension of velocity is l1 t minus 1, and we know the dimension of mass, that is m is m. So by equating the above equation, that is E is equal to k m to the power a c to the power b, we can get that m1 l2 t minus 2 is equal to m to the power a l1 t minus 1 to the power b. And from here we can get a is equal to 1 and b is equal to 2. So here E can be written as k mc square. Here k is a dimensionless constant. Then let I be the current through a conductor, R is its resistance, and V is the potential difference across its ends. According to Ohm's law, product of two of these quantities equal the third. Obtain Ohm's law from dimensional analysis. Dimensional formula for R and V are m1 l2 I to the power minus 2 t to the power minus 3, this is for R, and m1 l2 t to the power minus 3 I to the power minus 1 is for V or potential difference respectively. So let's begin. And here the dimension of I is given as m1 l2 I minus 2 t minus 3, and V as m1 l2 t minus 3 I minus 1. So when we divide equation 2 by equation 1, we can find the result as V by R is equal to m1 l2 t minus 3 I minus 1 whole divided by m1 l2 I minus 2 t minus 3, and the result is found to be I. So the Ohm's equation can be written as V is equal to IR. Then the frequency of vibration of a string depends on the length L between the nodes, the tension F in the string, and its mass per unit length m. Guess the expression for its frequency from dimensional analysis. So let's begin. And here's our solution. The frequency of vibration of a string depends on the length L between the nodes and the tension F in the string and its mass per unit length m. So we know the dimension of omega is equal to t to the power minus 1, that is the frequency, and the dimension of F is equal to m1 l1 t minus 2. Dimension of m, that is mass per unit length, is m l to the power minus 1, and by dimensional analysis we can get the result as t to the power minus 1 can be written as k by l root over of m1 l1 t minus 2 by m l to the power minus 1. So here omega or f, that is the frequency, can be written as k by l root over of f by m, and here k is the constant. Then test if the following equations are dimensionally correct. So we are given four equations where h is the height, s is the surface tension, rho is the density, p is the pressure, v is the volume, and eta is the coefficient of viscosity. Here nu is the frequency and I is the moment of inertia. Here you can see four equations. So we have to check this is dimensionally correct or incorrect. So let's check the first one, that is h is equal to 2s cos theta by rho rg. So we know the dimension of h is L, that is height in terms of length is L. Dimension of surface tension S is force per unit length. So here the dimension will be mt minus 2. Then the dimension of rho, that is mass per unit volume or density, is m L to the power minus 3. The dimension of r is in terms of length, that is L, and the dimension of g is gravity, that is the acceleration, L t to the power minus 2. So by putting the dimension in the equation 2s cos theta by rho rg, we can get the dimension h L, and which is equal to the dimension of h L. So here the uh, option A or question A is dimensionally correct. Then B. Here V is equal to root over of P by rho. Here V is the velocity, P is the pressure, and rho is the density. So we know the dimension of velocity is L t to the power minus 1. The dimension of pressure is force per unit area, that is equal to m L minus 1 t minus 2. And the dimension of density rho is m L to the power minus 3. So by putting the dimension of all the equations, again we will find that this equation is dimensionally correct, and here it is L1t minus 1. So option B or question B is also the right one. Then C. Here B is given as pi p r to the power 4 t divided by 8 eta L. Here B is the volume, P is the pressure, R is the length, T is the time, eta is the coefficient of viscosity, and L is the length. And accordingly we know the dimension of volume is L3, dimension of pressure is m L to the power minus 1 t to the power minus 2, dimension of R is L, dimension of T is T. Then the dimension of coefficient of viscosity, we can get it from the formula F is equal to minus eta dA by dt, and here the dimension of eta can be found to be m1 L to the power minus 1 and t to the power minus 1. And again the dimension of L is L. So by putting all the dimension according to the quantity in equation, that is V is equal to pi p r to the power 4 t divided by 8 eta L, we can found the dimension of pi p r to the power 4 t by 8 eta L h L cube, and which is equal to the dimension of volume. So this is also dimensionally correct equation. Then the D part, that is nu is equal to 1 by 2 pi root over of mgl by I. So here V is the frequency, m is the mass, g is the gravity, L is the length, and I is the moment of inertia. We know the dimension of frequency nu can be written as t to the power minus 1. Dimension of mass m is m itself. Then dimension of gravity g is L t to the power minus 2, and dimension of length is itself L. And again the dimension of moment of inertia, we know that I is m L to the power 2. So by putting all the dimensions, we can found that the dimension of 1 by 2 pi root over of mgl by I will be t to the power minus 1, and which is equal to the dimension of frequency. So this is also dimensionally correct. Then the last question of the first chapter and also of the current session, and here it has been asking that let x and a stands for distance. Each integration over dx by root over of a square minus x square is equal to 1 by a sin inverse a by x is dimensionally correct. So let's check. And here it has been given that integration over dx by root over of a square minus x square is equal to 1 by a sine inverse a by x. So the dimension of LHS side will be, the dimension of dx will be L, and the dimension of a square minus x square will be L square. So L by root over of L square, that is equal to 1. These two will cancel out each other and this will be dimensionless. And let's check the dimension of the RHS side, and this will be 1 by a, that is 1 by L. And because this is sine inverse a by x, so this is we can say this is an angle and this is dimensionless, so the dimension of RHS side will be 1 by L. So here 1 is not is equal to 1 by L, so this is dimensionally incorrect. I hope you all enjoy this session. So for more videos, please do like, share and subscribe. Thank you.